want to talk about the shortest job next or shortest job first algorithm for CPU scheduling. So let's follow us and support us with comments, like, and share our videos. So let's start some example about the SJF as a non-preemptive algorithm. Okay, now in this video we want to talk about the shortest job next or shortest job first, which is a non-preemptive scheduling algorithm. So the preemptive form of this algorithm, we call it shortest remaining time or SRT, that we talk about it in another video. So now here, as you can see, we have a process. We have four process, and at the time 0, as you can see here, so as you can see here, in time 0 we only have P1. So P1, our scheduling start with P1 because there is no other algorithm processes to be scheduled. So P1 start scheduling between 0 to 2, as you can see, and then at time 2 we have two processes, P1 and P3, P2 and P3. So between them, because the burst time for P2 is 4 and P3 is 3, we choose P3 because it has the shortest burst time. So P3 start to work between 2 to 5, and until in 5 also P4 is coming to the ready queue. So P1 and P3 got the CPU. Now we have P4 and P2. Between P4 and P2, because the uh, burst time for P4 is less, it's 1, we assign the CPU and allocate the CPU to the P4, and between 5 and 6 we have P4 here, okay, as you can see here. So after that, so we have only one process left. We schedule the P2 and assign the CPU to the P2. So P2 here between 6 to 10, allocate the CPU and start to running. We use here shortest job next, okay? So now we want to start to calculate the waiting time and also turnaround time. So for now, for turnaround time, as we mentioned in our CPU scheduling video, we must know the finish or completion time for each of the process and decrease the arrival time from them. So for P1 is complete at 2, so and arrive at 0. So the result turnaround time 2 minus 0. For P2, as you can see here, completion time is 10 and arrival time is 0, as you can 1, as you see here. So 10 minus 1 is turnaround time for the P2. And for P3 also, the 5 is the completion time and 2 is the arrival time. So 5 minus 2 is the turnaround time for this process. And for P4, it's completed at 6 and arrive at 3. So 6 minus 3 is the turnaround time for this process. So as you can see here, 2 minus 2 is 2 minus 0 is 2, 10 minus 1 is 9, 5 minus 2 is 3, and 6 minus 3 also 3. So 2 plus 9 plus 3 plus 3, we have 17, and we have a 4 process, so average turnaround time, we divided 17 to 4 and we got 4.25. And also for waiting time, we have the turnaround time here for each process, and then we must decrease the burst time for each process from the turnaround time to get the waiting time. So turnaround time to P1 for P1 is 2, and also burst time is 2, so 2 minus 2. The turnaround time 9 for P2, and burst time is 4, 9 minus 4. 3 turnaround time for P3, and burst time is 3, 3 minus 3, and 3 turnaround time for P4, and burst time is 1, so 3 minus 1 we have for P4. So as you can see, 2 minus 2, 0, 9 minus 4, 5, 3 minus 3, 0, and 3 minus 1, 2. So all of them together, we got 5 plus 2, it got 7 divided by 4, and we have 1.75. And as you can see, it must be not 5, it is 7. Okay, so 7 divided by 4, we got 1.75, as you can see here. Okay, let's go another example and talk about another example. Okay, for the next example, we have P1 to P5, while 3 of the process arrival time are 0. So at time 0, we have 3 process, as you can see here. So we have 3 process, P1 to P3, and the burst time is 6, 5, 7. So based on the algorithm shortest job next, we choose the shortest one. So we choose P2 for the first algorithm. So as you can see here, between 0 to 5, because the burst time is 5, we got, and the algorithm is non-preemptive, and we cannot deallocate the CPU. So we we allocate the CPU to P2 between 0 to 5. At time 5, P4 and P5 also in the ready queue. So we have P1, P3, P4, and P5. As you can see, between them, the shortest uh, burst time is going for P5. So we allocate the CPU to the P5 between 5 to 6, and it completes at 6. So then between the process P4 with burst time 3 and P1 and P3 with burst time 6 and 7, we allocate the CPU, of course, to the shortest one, P4, and between 6 to 9 CPU allocated to P4. Now at the end, we have only 2 processes, P2 with 6 burst time and P3 with 7 nanosecond burst time. So between them, we allocate the CPU to the P1 because 6 is less than 7 here. And between 9 to 15, CPU is allocated to P1. And at the end, of course, CPU is allocated to the P3 with 7 nanosecond burst time. So as you can see, we draw the Gantt chart here. Let's go and calculate the waiting time and also turnaround time. Okay, so as you can see here, turnaround time for process 1, the completion time is 15. So 15 minus arrival time 0. Okay, here. The next one, P2. P2 completion time is 5 and arrival time is 0. So 5 minus 0. The next one, P3. P3 completion time is 22 minus 0 because the arrival time for P3 is 0 also. And then for the completion time for P4 is 9 and P5 is 6. So 9 and 6 minus the arrival time for P4 is 2 and for P5 is 4. So turnaround time is like this. So if we calculate each of them, 15 minus 0, 15, 5 minus 0, 5, 22 minus 0, 22, 9 minus 2, 7, 6 minus 4, 2. So as you can see, we add them together and we got 51 divided by 5 because we have 5 processes and we need to calculate the average turnaround time. So average turnaround time here is equal to 10 minus 2. And for waiting time, we have the turnaround time for each process. Just we need to decrease the burst time for each process from this turnaround time and calculate the waiting time. So 15 minus the burst time P1, 6. 5 minus the burst time P2, 5. 22 minus the burst time P3, 7. And 7 here minus 3 burst time for the P4 and 2 minus 1 burst time for the P5. So as you can see here, we got 9 here, 0, 15, 4, and also 1. So 29 divided by 5, we got 5.8 for the average waiting time for this example. Okay, let's see another example here. So also we have here 5 process and with so which variety of the arrival time and burst time, as you can see here. So arrival time we have got here and burst time we got here. Also priority, which is not useful here for us, just for the time. If some process have the same burst time, we can choose based on the priority, of course. Okay, so now as you can see here, for the first time in time 0, you only have P1. So P1 is started to run between 0 to 3 because it's non-preemptive and must complete. And after that, in time 3, we got 3 more processes, P2, P3, and P4. And between the burst time 8, 7, and 5, we have to choose the shortest one. So we choose the P4 here, because 5 is less than 7 and 8. So we got here. So between 3 to 8, we got P4. Until 8, also P5 is in the system. So we have P2, P3, and P5. So based on the shortest job first, we choose the P5. And between 8 to 10, as you can see here, we have 2 burst time for P5 here. And at the end, we only have P2 and P3. So between 7 and 8 burst time, we choose 7. So between 10 to 17, we allocate the CPU to P3. And between 17 to 25, we allocate it to P2. So this is the Gantt chart for this example also. Let's start to calculate the turnaround time and waiting time. So for turnaround time, we need to, as we know about that, we need to decrease the arrival time from the completion time. For P1, the completion time is 3 and arrival time is 0. So 3 minus 0. For P2, completion time is 25, but the arrival time is 1. So 25 minus 1, you can see here. For P3, the completion time is 17. Arrival time also 1. So 17 minus 1, you can see here. The next one, for P4, the completion time is 8 and arrival time is 3. 8 minus 3. And at the end, P5 completed at 10, arrival 4, so 10 minus 4. So as you can see here, 3 plus 23, 24, 16, 5, and 6. So we add them and divide it by 5 because we have 5 processes and we need to calculate the average turnaround time. So 54 divided by 5, we got 10.8 for this example. For waiting time also, we have the turnaround time for each process here and just decrease the burst time for each process. So first time 3, burst time 3, 3 minus 3, 24, burst time 8, 24 minus 8. Next one, 16, minus 7, because P3 burst time is 7. 5 minus 5, and 6 as a turnaround time for P5, minus 2 as a burst time for P5. So as you can see here, for calculating them, this one going to 0, 16, 9, 0, and 4. So addition of them together, 29 divided by 5, and we got 5.8 for the average waiting time for this example. Okay, this I hope all of you knows about how you can schedule process using the shortest job next. So please see another video of the
Okay, thank
CPU
you very much
scheduling to
for
knows more understanding
watching
about
my video,
other
and please
scheduling algorithm.
support us with subscribe, like, and also comment, and also introducing this video to your friends. Thank you very much.